I mean, the ultra-realistic heavy ion physics started, I think, in the late 70s, not here in Europe, but in the US, in Berkeley, at an accelerator called the Beverlac. And there were initially only a few people, I think Germans were there, some Americans, of course, a few Japanese. And they started colliding these heavy ions at this high energy. And the idea, of course, at the time was already to see what happens if you collide these ions, if you create a very hot environment. Do you see some new phenomena? There were already first ideas about a new phase of matter. It didn't have a name yet. And they did find some interesting things indeed, the first time that collective flow was seen. And so they thought, now we have to go to higher energies, because they didn't find, let's say, the quark-gluon plasma yet at the time. And so they came to CERN, and I think the original idea, I think it was Reinhard Stock, Hans Gutbrot, maybe some others. The original idea was to use the PS, that is the small accelerator, the proton synchrotron, which was much higher energy than the Beverlac, but only about 20 GeV. Now at that time, actually, that was at the beginning of the 80s. One of the other big accelerators of CERN was about to shut down, the ISR, the intersecting storage ring. And some people who worked at the ISR were looking for new things to be done. And one of them was Bill Willis, who was a physicist at CERN at the time. And he became very interested in that. And so in discussion with Reinhard Stock, Hans Gutbrot, Specht and a few others, they actually decided not to go to the PS, but really to try at higher energy. So initially they were even trying to argue whether one can use the ISR, which is a collider, roughly of about the same energy as Frick. That was in the early 80s. But the ISR had to be shut down because it had to make place for LEP, because CERN had to shut down one accelerator to make another. So then the idea was to go to the SPS, which is much higher energy, about more than 10 times higher, or 10 times higher than the PS. And so then they set up a number of experiments at the SPS, I think 3 or 4 to start with. And actually, because it was a program which was done very quickly, what they did is they used experimental equipment from all over the place. So actually, part of the ISR experiment was transferred. There were parts of UA1, UA2, which also were done at the time. Equipment was used. Some part of the Beverlac equipment was taken, so everybody quickly put together an experiment. That was in the early 80s, and then we started 86. So the first experiments were 86. So as I said, in 86 we started with first light ions. Actually, the first beams were oxygen, so a very light nucleus. That was 86. I think the year after we had sulfur, or 2 years after. And heavy ions started only almost 10 years later, in 94. Because one had to make a new source and everything. But already then we saw that there were some interesting phenomena. We saw strangeness enhancement, we saw shape size suppression, we saw anomalous lepton pairs. So they were all the signs which were predicted for the quark-gluon plasma, but one wanted to go to much higher energy, to higher temperature. And at that time there was discussion of building RHIC, the relativistic heavy ion collider. That was a US project. Was discussed in the late 80s, early 90s. And because at the same time CERN was thinking about the next machine, which became eventually the LHC. And so then I think it was Carlo Rubbia actually who had the idea, if we build a hadron collider, why don't we use it also for heavy ion? So he supported that quite a bit. Yeah, so that was, all that happened at the beginning of the 90s. And that was the time when we had to build both the experiments for the lead, which started only in 94. We had people working on RHIC, which started in 2000, that was already discussed and built. And then there was the idea of the LHC. So there were 3 programs which hadn't started yet. So everybody was busy up to here, of course. So there was not a lot of people who had really time to full-time look into LHC. So everybody was working a little bit on the SPS, a little bit on RHIC, and a tiny little bit on the LHC. So at the beginning, we just said we make one big group, all the heavy ion experiments together, and we start with help from everybody to make some calculations and start with the design of the heavy ion experiment. But it was a part-time job for most people because of the other ongoing programs. But of course we started, essentially most people, I think everybody, all groups at least, maybe not all individuals, but most groups who were working on the heavy ion program at the SPS, some groups which were working at RIG, they all said, I mean, potentially it is very interesting, so we would like eventually to participate, but only once we have really time. So essentially all experiments had only a few people which could part-time work on it, and some of the younger people. So I remember Federico Antinori, who was now the physics coordinator, he was a young fellow, and so I motivated him a little bit, so he worked a little bit more of his time. Paolo Giubellino worked on it, Karel Safarik also, he worked on it, and some other people who are no longer in there, Franz Nowak from Bari. So whenever somebody came to CERN, either as a fellow or as scientific associate, I grabbed a little bit of them to work on ALICE in the spare time. I mean, this was a very imaginative experiment because we had no idea how it looks like at ALICE. You know, we were just starting at 100 times lower energy with much smaller ions. So when we started to write first ideas about ALICE, all we had was sulfur on heavy target at much lower energy. So we had to extrapolate enormously. So it was also very uncertain what type of detectors to use, what type of experimental conditions to expect. So the biggest challenge besides getting people was actually knowing what to expect. Actually we had no clue. With RIG it changed a lot. That after, let's say, 2000, 2001, we did learn a lot, and that's when we still changed a little bit ALICE. We added a muon arm, we added a transition radiation detector. Multiplicities were still uncertain, but it was already clear that they would come down a little bit from the very high early estimates. So after RIG, it started to converge, but of course at the time of RIG, a lot of ALICE was already well designed. We had started to build in 2000 the detector. The first part of ALICE which actually went into the experiment was built in the year 2000, actually in Russia. It's the carbon leather fiber which actually built. So by the time RIG started, the experiment was already quite well defined. So we started the design 1990, and the building we really started in 2000. But in between was a lot of R&D. I mean, we had to do a lot of design and development, develop the detectors, develop technologies, try out things, which was both because we had a long time. Actually, NHC slipped. When we started in 1990, we were promised it would start in 1998, 8 years later, so 1998. And then it slipped every year by 2 years, till about 2000. And so in order to use the time, we did a lot of R&D, and that was very helpful because we really had a new generation of detectors which we could use. Actually, I didn't come up with it. We had a competition. This was, so at the beginning ALICE was not called ALICE, it was called HIP-C, Heavy Ion Proto Collaboration. And I think the name ALICE, we had a competition only when we put in the letter of intent. So in Evian in '92 we didn't have a name yet. Actually at that time we had 3 proposals. One was a dedicated experiment, one was reusing a lab experiment, Delphi, and the third one was to use one of the planned PP experiments, either Atlas or CMS. And only the first and the last survived. So we built a dedicated experiment, but using a lab experiment did turn out not to be possible. Anyway, so the name, we made a competition, and unfortunately we don't have any record about the other proposal. I remember one, that was Lyon Codec, which is large ion collider detector. But we had a supermarket here which was also called Lyon Codec, and so that was voted down, and we stayed with ALICE. By the way, ALICE, at the beginning not everybody was liking the name, because in the English, in the Anglo-Saxon world, ALICE has a little bit of negative connotation. But the Italians and Germans have a very positive relation to ALICE, so we decided to use it anyway. Now, when we started in 1990, we had no idea what to expect. And in fact, some of the senior physicists for that was really the attraction. So Bill Willis, the one I mentioned before, was really instrumental in setting up a heavy ion program at CERN. When I asked him, I was a young fellow at the time, and I asked him, why should I continue in that field? Because actually I wanted to stop it. And he said, look, if you really probe QCD in a strong interaction, in an environment where it's really strong, where the coupling is strong, and that's heavy ion physics, then you were bound to find surprises. So why he really wanted to do it is really probe QCD in a regime where it has never been really looked at carefully, in the regime where the strong coupling is strong and at high density and temperature. And that was the main motivation at the time, really explore something new. Now we have found something very new and unexpected, because all the ideas we originally had were completely wrong. So in that sense he was right. We saw something very different. We saw, instead of a weakly interacting gas, we saw a strongly interacting liquid. And so today, what is interesting for people is maybe less this surprise, because we do know a lot. There are maybe surprises, but they are more quantitative than qualitative. But really now is to measure, make precision QCD in this new regime. That I think is what is interesting today. And there is still a surprise moment. We just actually had the proton nucleus collision, and there were plenty of surprises actually. So it's still the combination now, surprise, but also giving precise answers to well-defined questions. I think Alice has grown up from a little girl to a beautiful adult. I think it's looking very nice, it's progressing very well, so I wish it another 20 happy years at least. Actually, if one looks at the LOI, there are plenty of calorimeters all over the place. We had a far end cap, a near end cap. So we had 4 pi calorimetry. Now, the main reason for calorimetry at the time was to measure transverse energy. And that one can also do with charged particles. So that aspect can be done with charged particles. We had good charged particle calorimetry. This calorimetry would have been quite expensive and quite heavy and difficult to implement. I mean, even today we cannot implement. Now, at that time one could have done it easier. But at that time the main aim was looking at transverse energy. And jets were already a little bit known, but that was not in people's minds. So, and in some sense, the good justification for this big calorimetry was not there. It was also only electromagnetic calorimetry, so it was only meant for ET. There was no hadronic calorimetry behind. What today we know is that there is a good physics argument for that, which at the time was known but not very prominent. That's why at that time we didn't see a reason to add something which would have been quite expensive, quite difficult to add, and only have limited use, as we saw it at the time. If we would know what we would know today, we probably would try to get a calorimeter in right from the start.